So we have a couple of gym memberships. One from Causes Cool Gym and one from Morgan's Muscular Gym. So we're trying to run a promo. So what we want to try to do is simulate this or get an understanding of cost. What is the cost to sign up for these gyms? Okay. So in order to come with an equation, we need two variables. Okay. So in both of these cases, what might our two variables be?
Number of months.
So one is number of months. So what variable do you want to give that in? Sure. M is number of months. Because the cost of the membership, right, the cost for me to be in this gym depends on the number of months. If I'm there for 1 month, if I'm there for 12 months, if I'm there for the rest of my life, right? I want to find out how much it costs for me to be in this gym. Yes, Paul.
Another variable is F for the monthly fee.
F for the monthly fee.
What? Like you should probably space yourself out so you don't get the
Okay. So is the monthly fee affected by the number of months, Paul?
The number of months. No, okay. Well, that isn't my y value. Okay, if I think of this, if we just so I can help explain my point.
Sure, yeah.
If we think of this y equals mx plus b, our value of m would be our x value, and then f would be our m value. So.
Okay. I'm a bit lost with all the math jargon. I'm trying to break it down a little bit. So you say that because we don't have x's and y's, right? But we want to talk about independent variables.
Oh, you're only. I thought like all our variables, not just. Oh, I didn't necessarily understand what you were asking. I thought you were asking for every single variable in the equation.
Well, that could be a monthly. I mean, you can come up with variable f for monthly fee. I'm just wondering I'm asking how this relates to the cost of everything and how that is either the independent variable or the dependent variable.
Yeah, so the cost would be the dependent. We could assign any variable.
So the monthly fee is
the monthly fee isn't any. Monthly fee would be the slope.
Okay, so can I erase this?
Yeah, sorry. I didn't understand what you were asking.
Okay. So you said another variable then.
C for cost.
C for cost. Okay, so C is equal to cost of the membership. Okay. I mean, even without breaking this down, I saw a lot of you just coming up with, well, how much would it cost for this membership I was there for 12 months? They just came up with some sort of equation. So for Causes Cool Gym, what kind of equation can we come up with to determine the cost based on the months? Andrea?
C equals 40 plus 20.
C is equal to 40 plus 20M. Can you explain to us how you got that equation?
So the cost of your membership will be the initial of $40. So that's the 40 plus, and then
Okay.
20 would be your monthly fee. So however many months you have is represented by it.
Right. So our cost fluctuates with our months. Right. Depends on the number of months that we have, and that's spending on $20 a month. Okay. So how can we graph this then? So if I was to put, well, which one is my independent, dependent variable? Well, which variable? M, months, or cost? Which one is the independent variable, which is the dependent variable?
No, the
Which one's affecting the other?
months is technically cost.
Yeah, so months is affecting the cost. So here, we'll have M for months. That goes along our x-axis, so to speak. And here will be a y-axis. So it'll go something like that. And then I'll number it, let's go by 20 here. 20 40, 60, 80, 100. Okay, and so on. Okay, so how can I graph this then? C is equal to 40 plus 20m. That's,
Well, you start your point at 20.
sorry?
Wait, you start your point at 40. Wait, which one are we doing?
C equals this equation here. C is
40.
equal to 40 plus 20m.
So you start your point at 40
Oh, yeah.
and
Start
0.
point at 40.
Because
40 on the y-axis over there. And add 0.
Oh, 0.
0,
Okay.
40.
So that's important to say. 0, comma 40, because when the month is 0, how much are we paying?
40.
40, right? So right at the beginning, boom, $40 out of my pocket.
Thank you.
Yeah, thank you. Thanks, Mr. Collins. How do I get another point on my line?
You,
Thomas?
You just estimate a number,
Okay, what do you mean by estimated number?
like you were like a number like 20 times 2 is 4
Sorry, 20 times 2. So you just choose a number for m.
Yeah.
So choose a number for months. Good. So you want to choose m is equal to 2. Okay. So here, if m is equal to 2, we get c is equal to 40 plus 20 times 2, right? And so what do we get from that, Tom? 40 plus 40?
Yeah.
So the cost is really $80 after 2 months. After 2 months, it comes up to here. Right, and then we could draw a straight line. Not bad, huh?
yeah.
You did better. Okay? So that's how we get that one equation for causes Jim. So we want to do the same thing with Morgan's muscular Jim. So Morgan's muscular Jim, what kind of equation can we come up with that? Paul?
C equals 20 plus 20 or 20 plus 20.
Okay, so do you see that we still have the same variables? Right, even though it's a different context in terms of we're talking about another gym, we're still talking about cost and the cost depending on the number of months. Right? So we still have the same variables, but we just come up with a little different equation because Morgan is charging us different things. Okay? So what would be the equation here, Paul?
C equals 20m plus 20. You could switch it around.
No, I like it this way. Right? Do you see that how this is almost looking like it's a y equals mx plus b?
That's
Except that we're not using y and we're not using x. And I don't want you to be so stuck on those variables. What I want you to recognize is this sort of relationship between cost and price. Cost will always have a fixed cost, that $20 initial fee. Everything after that, well, it's variable. It depends, right? It depends on the number of months. So here we got this equation, C equals 20, because basically the initial cost is $20 for Morgan. And he still charges me $20 a month afterwards. So how can I graph this relationship? So we're doing the same thing, right? If it's 0 months, so we talk about what are we doing here when we do m is equal to 0? What are we looking for? What is the term that we use? Lost cost. And we said that equals to 0. What value are we actually getting?
Oh.
Oh.
Or what
Just get
point?
one.
Sorry, what point? Or what value? What point?
Y.
Yeah, we just get the
C
y-intercept. Here in this case, we get the c-intercept because we're actually getting c. But basically, we're getting the intersection where our independent value is 0. So here it's 20. So so now that we recognize that this is a slope, right, it's a linear equation, we can just use slope as well, right? So what's the slope of this equation, or what's the rate? What's the rate? Yeah? Yeah, the rate's 20, right? That rate is in fact multiplied by our months, that's affecting our total cost. So for 1 month, we go across 1, up 20. Or we do rises 20 across 1. Okay? So notice that I'm doing the slope based on not the number of lines, but the actual values. So the slope is 20, so I went up 20 points, or 20 value, and across 1. I can do the same thing likewise. And there, well, that one's not so good. Hopefully you drew your lines with the ruler. Okay? So here we have a graph that basically just models the 2 gym membership costs. One from causes and one from organs. Tell me something about these lines. How can you describe these 2 lines? Sorry? What did you say? Both in the same direction, they're both positive slopes. They're parallel. Okay. What's parallel mean?
The lines will never forever going. No.
Well, both lines will be for always forever going. That's why we have the arrowheads. See?
They're like a mirror image of each other, kind of thing. They're like exactly across. Like that's what they mean by parallel.
Okay, I think they were saying, so the lines are equal distance apart, right? As Leanne says, they will go on forever and they'll never meet because they're always the same distance apart. Okay? So here we're going to hand out, actually no. So here we notice that 2 lines are parallel. They will never meet. That is, they will never meet. So we go back and look at our equations. So one was C is equal to 40x or 40m plus 20. No. First. It's 20m plus 40. So this was causes. And the other one was C is equal to 20m plus 20. That was organs. What do we know also about the similarities of these equations?
Same format.
What do we know? What do you mean by the same format, Paul?
It's based off of, I know that you don't want us to use this, but it's okay. It's based off of the y equals mx plus b formula.
Okay.
And it is, they're both based off of the number of months.
Okay, so they're both in that y equals mx plus b kind of form. Okay. What are similarities that we notice with these 2 equations specifically? What can we kind of see from there? What kind of can we see? Okay. So look at our equations. What can we actually see from there? What's the similarity that we see from there? Invoke your powers of observation. See?
They both charge the one. Each charge the same each one. So
They multiply the same each month. How do we see that in this equation though? What is the same then?
Same that
Just in our equation, what's the same then?
or the amount
Well, what number is that?
the 20.
Yeah, so we see that the 20 here is common in both. And so Dean, you said that this was what?
Oh,
The monthly
the monthly cost paid.
the monthly rate. right? Cost or rate. But what is that specifically in our equation though? We have a special name for that part of our equation. Andrea? Yeah, it's a slope, right? It's that number that we multiply by the independent variable. It's that rate that it constantly changes by. So here we know that the slope is the same. So I just want to do a little practical example that demonstrates what happens when it looks like when two lines are parallel. It's sort of like the consequences of that. Not consequences, but how we kind of get there. Okay, so you already kind of did the first part on your sheet. No, you can try to fill this out. Let's go and kind of review for a test or whatever. You can fill it out again later on. Everybody got one? Everybody got one?
Yeah, we got
So under summary, we could write, so two lines are parallel if they have the same slope. We saw that at that example. They both have a slope of 20, and they just keep going up the same rate. They'll never run into one another. Parallel lines never meet as they're equal distance apart. Something that Dean was saying. Finally, the symbol for parallel lines is two vertical bars. Yes. So for example, we would say line 1 is parallel to line 2, if we were to label those lines on the graph. Okay, everybody got this now? So I want to talk a little bit about what's happening when these lines, why they never meet, and how it's related to the slope or the rate. So we both start off at 0 months. The red one starts off at $20 for its initial cost. The green one is 40. What happens after the first one? How much should both of them increase by? Leanne?
the same amount.
Which is what? 20. So this one, if I would have drawn my lines nicely, should have been over here. But this one, we saw, well, it goes up 20 as well. What happens to the next one? It goes up 20 again. So it's going to go here. Oh, yeah, it's going to go there. And for the red one, where we got what? It's going to go there. After each month, each one is going up by $20. Right? They're going up by the same rate. Will one ever catch the other? No. It's like if I'm walking after Vince, and he's taking 5 steps a second, and I'm taking 5 steps a second, assuming our steps. are the same size, we're going at the same speed, I would never catch up to you. We're going at the same rate. So that's how we kind of time rate into slope. We have a little line, the lines will never intersect then. So let's look at some concrete examples. So example number 1, we have these two equations. Y equals 2x plus 1, and y equals 4y equals 8x plus 3. Are these two equations, are these two lines parallel?
Yes.
So say yes. You people said yes? How can you say yes? Yeah, I'm getting it.
Because if you divide the 4y by 4, it's y, and then 8 by 4 is 2y.
Why am I dividing 4y by 4?
Because you try to take 8, you try to take the x like that matches each other.
Well, they don't. Well, and here I got x is equal to 2, right? And here x is equal to 8. They don't match. I mean, I can see that. Why did you divide by 4?
Because so you make it equal. Because you try to make 4y into y, and then you divide by 4.
Why am I trying to make 4y into y? Why are we making ourselves, why is it making life complicated? Why do we want to divide y by 4y by 4? No? Thomas?
With the same y value.
Well, they won't both have, we don't know if they have the same y value. I know what you're trying to say it another way. Yeah, well, we get y by itself, right? We want to isolate for y. Why do you want to isolate for y again? Why is it important in the equation of a line, we want to isolate for y? Why is it that we want to do that? Who here? Well, not only good for y yourself, what else does it tell us? The slope. Thank you, Leanne. Right? This equation over here, the second one, it tells us nothing. Right? We don't like that form. Right? What's our favorite form for equation of a line?
Y equals mx plus 3.
Y equals mx plus 3. And why is it our favorite?
Simple.
What two things does it tell us?
Slope is not parallel.
Good. Which one tells us the slope?
It's m.
Yeah, so the m
It's not.
tells us the slope, and the d tells us the y-intercept. Okay, so write this down in your notes again. So we need it in that form in order to know before we can say what the slope of a line is. It has to be in that form. Well, is the first equation in that form already? So what's the slope of this one? What's the slope of this equation? Yeah, m is equal to 2. How can I determine the slope of the second equation then? We want to isolate for y. So that is your answer, Jenny. Your process is absolutely right. Now we understand why we're doing that. So we got 4y is equal to 8x plus 3. We want to isolate for y because we love that y equals mx plus 3 score. Question, Pooja?
I just wanted to
Okay.
You know how like when you say like the slope is 2, like 2 what? You know?
2 times our independent variable. System growing by the rate of 2. Right? So you can't say by what until we put the actual question in context. Right? So this creates all we can say is growing by 2 times the value of x.
Okay. So if x was like in kilometers, it would be like 2.
Yeah, it would be like 2 kilometers per hour.
Oh.
Okay? So we talk about ratio. Slope was always a ratio. It was a fraction. So you had a unit, usually have a unit on top and a unit on the bottom.
Okay.
Okay? So here we divide both sides by 4. So y is equal to 8x plus 3 over 4. Okay, so that's how we would normally isolate for a variable. Yes, Nicholas? Pick up your lung too while you're Do we want to leave it in this format though? No, because it's not in that y equals mx plus b form. So we want to break up that 4. We got y is equal to 8x over 4 plus 3 over 4. And we can simplify this part to be 2x plus 3/4. So here we can see that this equation has a slope of 2 as well. Okay? So therefore the two lines are parallel. Oh, look at that. The main use of our new symbols. Okay, so instead of writing parallel all the time, you just say the two lines are, let's say 2 L's, 2 big vertical bars. Because the slopes are the same. Okay. Questions on that example? Right, so we just try to hammer home the idea that two lines are parallel and the slopes are the same. So here's another question. Find the equation of the line parallel to y equals negative 2x minus 5 that's passing through the point 1, 2. I think I worded a little bit better on the actual document. So here, how do we find that? Right? We want an equation of the line that's parallel to y equals negative 2x minus 5, and it passes through 1, 2. How can we start? How can we start? We want an equation of this line, so try to picture in your head, this line that that's parallel to this other line that's going to 1, 2. Where can we start? Where can we start coming up with this equation? Where can we begin? This?
Draw the first line.
Okay, we can draw the first line. How would we draw the first line?
Well, it has those y-intercept of -5, so you already know that.
Good, so we have a y-intercept of -5. So we're going to do this line in blue. Okay?
And then it passes through 1, 2.
So it passes through 1, 2. So 1, 2 is here.
And it has a slope of -2.
Which one has a slope of -2?
It's parallel, it doesn't. Wait.
You might want to reread the question,
And passing through. Find the equation of the line parallel to y equals -2x minus 5.
So couldn't you just
That's it,
that
though.
first?
Well, I like Vince's idea. So let us draw this equation first.
And then we can see what's there.
Okay?
Wait,
So-
no, but
So we got this point here. How can we get another point on this line? Would you?
what? Couldn't you do 1, 2?
Well, how could, well, we don't, this 1, 2 may or may not pass through this line. We don't know. We just want to know what it's parallel to. So let's just graph this one first. So we got a point. How do we get another point on there? What information are we given? Yes, Andrew?
If it passes through 1, 2, could you just kind of like cheat?
It doesn't say that this one
No, I'm
passes.
not saying that one. We're trying to find a line that's parallel to that equation that passes through 1 and 2.
Yeah.
Couldn't we see like the rise of a line kind of thing?
Good.
And see where 1 and 2 are, and then you can do that with that line, with that dot.
Okay.
Is that like right, or is that completely
Well,
like?
what?
No, that's absolutely right.
Okay.
I just want to finish drawing what Vince is saying first, so that we can visualize, and hopefully people make that what you're seeing. Okay.
It's equal to that equation, but it passes through that.
So here we got this point. Vince said it was y-intercept. So what's the slope of this line?
2, -2.
-2. So what does that mean we go from here? Up or down?
Down.
Down 2 over 1. Down 2 over 1. Oops. Over 1.
It's like rise over run.
Rise is -2. And 1 is 1.
Oh my goodness.
So here's our line like that. Okay. So does that line pass through 1, 2? No, it doesn't even come.
But just
The line that they're talking about, the line that they want you to find the equation of,
Yeah.
passes through.
So we want a line that passes through this point, so I can change the color now. We want a line that passes through this point, but it's parallel to our blue line now. So Andrea, how are you saying we get that?
you take one point, like you do the rise over run for the blue arrow, like that, and then you see the rise over run, and then you just do that with the red dot, and it'll be parallel.
Okay, why do you take the rise over run from the blue equation? Why are you taking it from here and using it for the red one?
Why wouldn't you?
Well, why would I?
Because it went from there, you have to follow the.
No, this equation is for the blue line.
But it's the same, if it's parallel, it'll be the same, like rise and run.
So what do we call that?
Relation, parallel.
No?
Slope.
It's slow.
This is busting gut back there.
It's slow.
Same slope, right? We just talked about the same slope.
I misunderstood the question, but I got it.
Yeah,
So-
you're right, I didn't get the question.
So here whatever line passes through this red dot is going to be parallel to our blue one, has the same slope. That's what we talk about parallel, right? It has the same slope. So we're going to do the same rise over run over on the red dot.
I told my mom to drop off some medicine for me.
Aren't you achieving in a
Just go. Everybody else, focus back here, please. Okay? So rise is -2, run is like this. Right? So we have a line that looks something like, if we drew it over the ruler, we get a line like that. Okay? So now that we have a line that's parallel to our blue one, that passes through 1, 2.
Yes.
Yes. So the key there was getting that point 1, 2 is because passing through it, right? But we're getting the slope from the other equation because the two lines are parallel. So we can kind of steal the slope from the other line because we're given that information that they're parallel. So parallel lines have the same slope. But how do I calculate the equation for this?
Oh, yeah.
How do I get the equation for this? Katie?
Well, you already did the first part, it's -2.
Okay. So we ask for an equation of a line, first step, always. Write down what we're going to start with. Okay? We know we're going to be looking for equation of a line, y equals mx plus b. That's our favorite form. So Katie, you're saying that what?
You already have the first part, which is y equals -2x,
What's that first part? What's that name?
the slope.
So we already have the slope. We know it's the same as the other one. Right? Actually, it's about the -2 in there. So -2x plus b. So is that our equation then? Thomas?
No, you want the y.
Yeah, so what's the y-intercept here? So graphically, we can see that it's 4. Right? Here we kind of see, and even when we did another rise over run, we go up 2, but because we go up 2, we can go to the left, and we see that it does fall to 4. So it goes y is equal to minus 2x plus 4. Okay? So that is our equation. Any questions on how we got here? Yes, Paul? Hurry up, please. Okay, so I'm going to show you something now that might blow your mind a little bit. But you need your focus for 5 minutes because this concept is vitally important. Okay? So let's stand up, stretch if you need. Right? This next point is going to be important. Important for Raven of the year. It's going to be important for next year when we do quadratics. Okay, we're good? Oh, I got it. Just leave it unlocked.
Then come back, it's like, I know they're there and I look at them. It's not like I don't.
Okay, so you guys want to take this on those two? I'm going to do it in blue. Okay? This is a different way to just get the answer we just got. Pretend that you couldn't even graph this. Right? I gave you numbers that you could not graph. So we can come up with this equation of a line that's parallel to this. So what are we going to start off with? Right off the bat. Thank you, Andrew. Y is equal to mx. So every time we ask you, find the equation, what is the equation? Let's just start off with what? What are the two things we need to figure out? Okay, M and D, right? Our equation is always going to have y and x in it. We need to figure out what M and D is. So from here, no different than before, what's our slope? It's going to be -2 because it was parallel to this line. So we're just going to steal the slope from that equation and just say, well, it's minus 2x plus b. Now here's the, might be difficult part. Stay with me. How are we going to get b? Well, what is it that we know about this red line if we look at it? It passes through 1, 2. What does that really mean, though? What does it really mean when it says it passes through 1, 2? It's a point on the line. But what does that point on the line mean? And I want you to go way back when we talk about the computer program with input and output. What does it actually mean? We have a point passing through 1, 2. This is vital that you understand this concept. It's information, but how does this relate? How does it relate? Nicholas?
It's near the y-intercept.
It's not a y-intercept because it's 1, 2. A y-intercept has an x value of 0.
Oh, I said it's near.
Oh, it's near, okay. Well, it's kind of like near, I won't say it, but it's not, we need the exact answer, right? So you're right, it's near, but we don't need a point that's necessarily near. I could give you a point that's way far away, but what's vital about that point on that line though? What is the connection that we're drawing through the point in an equation of a line? Pooja.
We guess here. Input is 1 and output would be 2.
Yes.
So the pattern is
So here, what you're saying is, when x is 1, what is y then? So when x equals 1, that means y is equal to 2. That's what it means when it's passing through that line. Sorry, passing through that point, right? In this equation, when x is 1, y is 2. That is the relationship between our x and y. They're independent, dependent variables. So when x is 1, y is 2. We just go back to the equation. We know that because this equation is going to pass through that point, that means when x is 1, what's y? 2. So when x is 1, y is 2. But we still don't know what b is. But can we solve for b now?
yes.
Okay? So here I got 2 is equal to negative 2 plus b. How do I isolate for b? Add 2 to both sides. 2 plus 2 equals negative 2 plus b plus 2. I got b is equal to 4. Everybody follow that? So therefore, the equation is y is equal to, we figured out negative 2x. Now we figured out a b value, which is 4. So now we determine this algebraically without having to draw a graph and map back to the y-intercept. If I gave the question that says, find the equation line parallel to y equals negative 2x and 5, and there's this point 5 comma 6. No. I didn't say it has to pass through that point. The key is that line has to pass through that point. Then that means that this makes that equation true. Okay, so I can't give you just some random point out anywhere. I have to give you a point that the line passes through. So this part is key, right here, passing through.
So it's always gonna be.
And chances are we'll always say that the line passes through these points. And that'll tell you that I can plug in my x and y into our equation then. And that makes that equation true. Okay, plug in x and y makes that equation true. So that, I mean, you can confirm that by, now that we have our equation, y is equal to negative 2x plus 4. Well, what happens if I plug in x equals 1? I get y is equal to negative 2 times 1 plus 4. So y is equal to negative 2 plus 4. Y is equal to 2. So when x is 1, is y 2? I would have plotted that. So that's what makes that equation. Okay?
Oh, not bad.
No, it's not that bad, but it is vitally important. Okay? Any
So we
questions on
can do
that?
it either way, right?
So you can do it either way. This way will always be exact algebraically.
So if when we can, it's the better.
Always
option
try to
to
do it algebraically. And in fact, we'll do a lot more things algebraically from now on.
Yes.
So any questions on this? Any questions on this? Because there's one more topic I need to cover still. Oh, I got 2 more examples. Okay, 2 quick examples. Find the equation of a line parallel to y is equal to 2. So first of all, what does the line y is equal to 2 look like? What is the equation of the line y is equal to 2 look like? So if I was to draw a grid, what will y is equal to 2 look like? D.
I think it's on the x, and it's 2.
On the x.
No, I'm probably wrong.
No, it's right.
So it's on the x.
Yeah.
So I'm not sure what you mean by on the x.
On the x, it's positive 2.
So like this.
Yeah.
Because y is equal to 2, not x is equal to 2.
Oh yeah, so never mind, it's 0.
So I can erase pretty good. Right? So y is equal to 2. Right? So what's our slope really? What's the slope of this equation? It's not undefined.
0.
0x, right? So the slope is 0, it's flat. So here we go, y is equal to 2. So we want a line that's parallel to this that passes through 5 comma 6. So what would that equation be? So we want a line that's parallel to this, so what is it going to look like? Parallel to this, what's it going to look like? Yeah, straight, but you mean it's horizontal, right? Because this one's horizontal, they're parallel. It's going to pass through 5 comma 6. Vince,
The equation is y equals 0x plus 2.
y is equal to what?
0x plus 2.
Plus 2.
For this line.
No, but I want an equation of the line that's parallel to this.
Oh,
Passes through 5, 6.
okay, it's,
Read the question, what passing through 5, 6.
okay, so it's y, it's 5, no, 6. No, y 6, no, 6. 6.
Y is equal to what?
6.
Well, like what you said before, 0x, because we keep the same slope, plus 6.
No, wait,
Why is it plus 6?
no.
So x plus 6 is equal to y equals 6.
Well,
It's
let's
just-
plot out
it
where
keeps
5,
like-
let's plot out where 5, 6 would be. 5, 6 would be somewhere up here. So we want a line that's parallel to that. What's your y value?
Wouldn't it be 5? Wouldn't it be 6 though?
Yeah, our y value is 6, so that's why it's y is equal to 6.
Oh,
Because the line y is equal to 6 is going to run right across where y is equal to 6.
that's a little easier.
Yeah, it's easy.
No, but just process.
You have to process it once but we know once you process it once, and you conceptually see it, that's where you make the connections, that's where it becomes easy. That's what I'm trying to lead you through. Good? Next
I
question.
told you I was equal to 6.
So find an equation of a line parallel to the vertical line passing 3, 4. How do we do that?
Oh,
15? This is Dean's part now.
Now you put it on the x-axis, put it at 3 or 4.
So now we want to come 3, 4. There's 3, the 3, 4 is over up here.
Yeah.
So what's a vertical line mean?
Up and down.
Straight up and down. Actually, it says find the equation of any parallel lines passing through 4. So we want an equation of any line that's passing through, that's parallel to this one.
So then just say,
So what's the equation of this line? X equals 3?
yeah.
So what's the equation of any line that's parallel to that?
x equals and then their x plot.
3, 5, 3, 2.
Okay? So it's just anything you want except for 3, because x equals 3 is that same line. We want a line that's parallel to it. Okay, so x could be 1 billion. X is equal to 1 over 1,000.
But it's still vertical.
It's still vertical. Question? Yes? Anything you want. Any number except for 3 you can put there. Because that,
Yeah.
think of it, give me a number. Well, we know that a vertical line, our equation is x equals something. So we want something that's parallel to it. So what's the slope of this line? What's the slope of a vertical line?
Oh.
Slope of a vertical line?
0. Undefined.
Undefined, right? Because we're dividing by 0, the run is 0. So we just want a slope, any line that has an undefined slope, which means x equals anything. Okay? You wait, but thank you. Okay, need to move on. So now I have a picture of another 2 lines, which was on the back. So what we're trying to do here is that these 2 lines are perpendicular. Okay? So how we symbolize that they're perpendicular to 90 degrees is that you have this little square symbol. So this implies that it's 90 degrees or perpendicular. Can someone come up with the equation for me for the blue line? Can someone come up with the equation for me for the red line? So the blue one for you guys is, so let's label it. Let's label this one L1. So the one that's going positive slope. And L2 is the one that's going negative slope. Slope. So somebody come up. How about this class? Like Nicholas and Leanne over, come up with L1. You guys come up with L2. Go. It's a race. Come up with the equation for L1 and L2.
Okay, we're good.
Too much difficult for me. Carry me. Are we L1?
Yeah.
Wait, what are we doing? L1 or L2?
Well, I need 2 points.
Guys, are we L1 or L2?
Prize will make me leave on time.
Where the blue line?
So, I think, what are we trying to find?
Equation for
Alternative. Oh, okay.
Which one's
It's easy. It's easy. Just pick any.
the slope is y equals mx plus
Guys, I found the
negative y.
You don't have the
I
y.
found two spots where the line intersects perfectly.
I think I found it. What is it? I got negative 4.
Yeah, you did.
No,
Yeah.
yeah, plus 1. I got 4. So I need
Oh.
No, you just need to find the
y.
Wrong.
Is
Y intercept is negative 2.
No, negative
What is it?
y
There's so many different answers.
3/4 x
Right.
It's because you do one. It's not that hard.
Did we lose all? Are you done?
I don't know if they're right or not.
Well, we got ours. Are you done?
What's yours?
Y equals negative 4 over 3 x plus negative 2. Plus, you missed the plus sign.
What?
Oh no, never mind.
You picked any two dogs.
Okay. Both teams are correct. Good job.
Yay!
On time. Okay, so write that down. So you got the bottom for one line, write down that first line. Then I was listening to you guys were finding what the y-intercept was, which was good. And then you try calculating the slope by finding where that line crosses 2 points, where you can kind of clearly see, sort of like at the crosshairs. Thanks, Nick.
Why is that 4?
Okay, so now looking at our equations, I want you to use your powers of observation. What do you notice about these two equations? What pattern can you detect between the blue equation and the red equation? What pattern can you kind of detect? Okay?
The fraction is flipped and it's negative.
So what's the fraction though?
Slope.
What does that represent?
The slope.
Yeah, so the slope, here we have the slope is 3/4. And here, the slope here is negative 4/3. So what we go from here is we flip it and we change the sign, right? So from a positive to negative, we actually get to that. Everybody see that?
Yep.
Okay. So we did this. So these are two lines. That's how they're related, right? So the slopes are flipped that in full. And the sign changes. Okay? So that when a perpendicular, this is what happens is lines crossing at perpendicular, 90-degree angles are very important in mathematics. So that's why we're kind of stressing this. Right? So take down these
Please
notes.
don't die on us, sir.
I thought it was the
Sorry.
Where do you write that?
Under the summary, there should be a summary section.
Oh, yeah, that's right, right?
Negative reciprocal.
The perpendicular lines meet at 90-degree angle. So that's what perpendicular means. They meet at a 90-degree angle. Perpendicular lines have slopes that are negative reciprocals. Remember what reciprocal was, right? It's just a fraction flipped, but it's a negative reciprocal. In other words, change the sign on it.
So like if it was negative, it'd be positive.
Exactly. Because there'd be a negative, which is a double negative, which you're not supposed to use in English, is actually a positive, right? So perpendicular lines have slopes that are negative reciprocals of each other. That is, flip the fraction, change the sign. And the symbol for perpendicular is this thing that looks like an upside down T. So for example, L1 is perpendicular to L2. Hey, everybody finish writing that down?
No.
Not fill in the blank.
Yeah, it is.
Yes.
What?
Fill in 3 words.
What?
I thought I removed that part. You guys got off easy then. Good?
No.
We're still writing.
Fill 3 words. I know, I still wanna have it.
That's okay.
You have
This
it.
was what you meant. You're supposed to meant to write it in full. Because that's actually how you learn better.
Okay.
So go through some quick examples. Example number 1, we have 2 equations. Are these 2 lines perpendicular?
No. Yeah, no, the first one. No.
No, the 2 lines, are they perpendicular?
Yeah.
Right here. Number 1.
Yeah.
So these 2 lines, are they perpendicular?
Yes.
Why yes?
I'm disagreeing with everyone else.
It's opposite.
Thomas,
Because it's also over 3 over 1, but if you switch that,
right? So what's the slope? The slope there is 3. So what's the reciprocal of that?
1/3
Right?
over 1
Because
third.
it's 3 over 1. The reciprocal is 1/3
Why is it negative?
and negative. So we have a negative reciprocal that matches this. So that's a positive. That's the perpendicular.
Hurts my throat here.
I know. I wanna like.
Okay, that was me like 2 days ago.
Yeah, it's disgusting.
That's why you sanitize.
Can I have your attention for the afternoon
Why you don't
announcement?
get this food?
With the following students, please come to the front podium. Chris
Black,
Sue,
please.
Jacob Haddad, Alex Marcoux, Daniel Lanyon, and would Mr. Rose and Ms. Dolkovich please call the front section? Please stand for a closing prayer. Bow your head. Go forth in peace, think evil of no one. Give tidings of God return, in Christ the world, amen. Thank you.
Okay, maybe 2 more minutes.
Yeah.
So these 2, are they perpendicular or not?
No.
How come?
It's negative. Our next isn't negative.
Yeah, first of all, you can tell right away, x is not negative. Both of them are positive. The slopes are both
If
positive.
x was negative, it would have been though.
Yes. So it's the same idea what we did before, what Jenny was talking about. We need to isolate for y in this case. So we're going to divide both sides by 6. So that will left us with 10 over 6 x minus 3, which is 5 over 3. x minus 3, but 5/3 is not the negative reciprocal of 3/5, right? It is the reciprocal, but it has to be the negative reciprocal, okay? And we see that when we saw the perpendicular lines, one slope was positive, the other one was negative, okay? Last one, are these two, do you have a question, Jenny, sorry?
They're not perfect.
Okay. Are these two, number 3, these two perpendicular?
Yes. No, they're not, because they're both positive. No.
No, wait, it is, because X is on the other side. Yeah.
No.
X is on
Is that in slope intercept form? Y equals mx plus 3 form?
No.
That?
Yeah.
Yeah. What's the slope here?
1.
What's the y-intercept? 0. Yeah, just don't see it. Here, is this a y-intercept form?
Yes. Yeah.
No.
No, we need to do what? Isolate for y. So here we're gonna subtract x from both sides. We get y is equal to minus x. What's the slope of this?
Yeah.
What's the slope of this? What's the slope of this equation? -1. 1 is the negative reciprocal of, sorry, -1 is the negative reciprocal of 1.
A bod mine.
So this is yes.
Fernando.
Come on, Ian.
What's the reciprocal of 1?
She got it.
This is interesting. 1 is the only number whose reciprocal is not a fraction.
Because 1 is space.
And 1 reciprocal is just 1. So for homework, do example number 2. Alright, so you're gonna do, this one was similar to the parallel line ones. Okay, this one's similar to the parallel line one, except now you're not stealing the slope. So you're taking that slope and you're doing something to figure out the other slope, and then doing algebra to get the y-intercept. This one is similar to the one we did before with the y equals to the horizontal line, so we want the line that's perpendicular to it. Don't worry about the final challenge, and then do these questions for homework.
Wait,
Yes.